Okay, let's see if this works. Okay, cool. So hopefully you enjoyed that. We're, as you can see from that video, we're a truly global and diverse business. Our network connects lots of kind of interesting assets in over 20,000 locations, 70 plus countries, and often in some of the most kind of poorly connected parts of the world. So, basically we're operating at massive scale and complexity, and so the breadth of cloud connectivity use cases that we see and their complexity tend to get amplified in our environment. And so we hope that some of the problems that we've solved and the way we've solved them will hopefully provide some useful reference points for all of you. Our journey to cloud started in 2015 when we declared that we would be a cloud-first business. And that was a pretty big statement internally within BP, and kind of basically said we wanted to get out of the business of running infrastructure. And one of the many challenges we faced was that our move to cloud was heavily constrained, our move to cloud, whether that be Amazon, SaaS, rolling out O365, it was heavily constrained by our legacy network. This network had been optimized for data center hosting. What kind of little business class internet traffic we had back then, we backhauled over MPLS links to central gateways and security control points in our data centers. Historically, IT had been seen as a hygiene factor in BP rather than strategic, and that's very different now. But that meant back then that we had the network had suffered from years of underinvestment, and so many devices were approaching end of life. Circuits were near capacity, and yeah, so I mean, I guess our agility was further inhibited by a set of outcome-based commercial agreements, which were kind of not optimized for rapid change, and so kind of typically they were underpinned by a lot of process-heavy governance. We'd outsource a lot of technical skills, and yeah, so it was just really difficult. So we kind of knew that we needed to completely rethink our approach to our network architecture and our operating model, and we set ourselves these 6 goals. Firstly, we wanted to facilitate access to rapid, performant, and secure access to a multitude of different cloud providers and cloud services. Secondly, to support the data center exit ambition of our cloud-first strategy, we needed to externalize our network exchange points, which historically we had located in our data centers. Thirdly, we wanted to be able to scale the network elastically to support rapid changing traffic patterns and traffic volumes, and support mass migration. Thirdly, it was also important for us to be able to deploy new network functionality on the network to support rapidly changing requirements. And so we wanted the ability to be able to keep to evergreen the network and keep the functionality of the network evergreen. Our overall IT transformation is about moving to a variable cost base with consumption-based charging. So we wanted to align the network to the rest of our core services. And then finally, we wanted to be able to deploy network functionality consistently across the network so that we could provide a consistent user experience. So I'm now going to hand over to Alai, who's going to take you through, or pick up the story here, and how we architected against these requirements.
Yeah. Thank you, Paul. Great context. I think we now have a pretty good idea in terms of the goals and outcomes that this network transformation had to achieve both operationally and functionally in order to achieve the cloud-first outcomes that we've planned for. So I think right now I'll try to go through how we went about this transformation and maybe describe the key building blocks of the network that we put in place in order to interconnect to AWS and other cloud providers. And I think the main concentration or focus for this session is primarily how our backbone evolved to provide that global and consistent way by which we connected to the cloud. So I think I'd like to jump in and start talk about the architectural choices that we had to make. And I think in making these choices, we effectively had to answer 3 key questions. So these questions were effectively, what was our cloud hosting objectives? What did it mean to be cloud first? And the second key question was, what level of trust we placed in the cloud? So when we say we trust the cloud, how do we trust it? Do we trust the security of the cloud, the reliability of the cloud, the feature richness of its services? And the third was how we as an organization, how ready were we to embrace a cloud-first strategy? What did it mean for us as an organization to do so? So ultimately, the answer to these questions was effectively kind of served the initial boundary conditions by which we thought about transforming this network. I mean, we understood early on that these answers were effectively a point-in-time view, and they would evolve over time as the level of maturity of our own organization and the maturity of the cloud services also matured over time. So, in our mind, the architecture that we had to implement, the network itself had to be flexible enough to account for these variations in requirements over time. So whether it was throughput, whether the points of presence where we had to extend this network, or even the functionality, we had to ensure that architecture was flexible enough and modular. So what did it mean to be flexible and modular in our view? It meant three things. First, we needed to decouple our services from the data centers because we wanted to facilitate exiting and closures of these data centers. So what that meant is we opted to co-locate whatever infrastructure components or points of presence at carrier-neutral facilities. And obviously, that provided us easy reach to a number of services from a marketplace, which was very different than the way we've historically approached communication and services, which we brought into the data center. The second thing was we understood early on that we needed to federate our backbone. So we come from a model where we had a global backbone anchored by, let's say, 4 or 6 points of presence globally. Now, when translating what cloud first meant, we understood that over time there will be an increase in demand for more and more local and regional hosting, cloud hosting regions. Simply because our presence, I mean, we operate in a lot of countries and we have a lot of line of business applications that would demand hosting, regional hosting. So that meant for us that we would experience an increase in the number of connection points and potentially an increase in the number of cloud service provider environments that we had to connect. So when we say federated backbone, what did that mean? What that really meant is we needed to move away from a global architecture in favor of a hierarchical regional-based architecture where we can effectively anchor that in multiple nodes or backbone points of presence that we would host at these carrier-neutral facilities. So think about moving away from having 6 points of presence to potentially 18 and providing optimal access into these cloud environments through those local connections. And third was we needed to have a modular architecture, which meant that even our backbone nodes, these points of presence, had to be designed so that they can be extended and have limited footprint, that we can introduce functionality easily. So what that meant is we needed to move towards a software-defined architecture. So that's the first time we as an organization, a network organization, we embraced software-defined architectures and network function virtualization. Okay, so I think that's architectural choices, but in addition to architectural choices, there was other implications. Coming from an environment where we were heavily outsourced, it meant that we had a multitude of third parties, suppliers that managed and monitored our network, ensured that it was stable and up and running. But it also meant that it drove innovation into our solutions. What that left us with is a lack of internal capability, whether it's skill set, resources, to actually embrace some of the newer technologies, disruptor technologies, cloud-native solutions and open source solutions. So it was very hard for us to experiment and stitch together solutions that we could deliver. So what that meant is that we were heavily biased in favor of best-of-breed solutions, right? Solutions that we've had previous experience with, they're purpose-built, previously integrated, we've tested, so we're comfortable. But also, we were quite favorable looking at vendors that delivered, an integrated technology stack. So a solution end-to-end that could deliver our network and security outcomes end-to-end. And that's actually quite evident in the choice of SDN fabric that we actually picked, and some of the virtual appliances that we currently run and implement in our backbone. The other thing is, of course, we continued the practice of consuming outcome-based management services because we, in parallel, had to start the process of upskilling our organization and scaling out that organization in order to bring in a new operating model. And one other key aspect, I think, that's fundamental here is that we also kept it simple. What that meant is that we effectively deployed these solutions and services, but we kept them very basic. They were very well understood patterns, very well tested patterns. There was no customization. And the reason we did that is because we wanted to kind of prioritize the availability and the performance of whatever we deployed over advanced functionality to address edge use cases. And it's actually really hard, but it was critical to us being able to maintain pace of deployment. And the other key area, I think, is our security posture. So what did it mean for us, the answer to these questions? Well, it meant that we wanted to continue extending our existing security practices because we simply didn't feel comfortable enough in what the cloud and the new way of working meant. So it meant central security boundaries, but we opted to distribute some of those controls that we implement centrally out to the cloud. It meant that we would continue the practice of micro-segmentation, but maybe replace some of the practices with what the cloud had to offer. But also, more importantly, some of the key and critical traffic flows that we managed, we opted to proxy them centrally. And I'll cover that shortly later on. Okay, so what does this regional connectivity model look like? I mean, this is quite a high-level view of what our connectivity into the cloud looks like in a particular metro. But effectively, we have the concept of a backbone node, and that backbone node effectively interconnects a number of networks. These networks could be internal networks, they could be external networks. But that backbone node effectively stitches together these networks in a very secure fashion. And it delivers really 4 key functions. It obviously serves as a termination point and an aggregation point for our voice and data transport circuits. Like I said, it interconnects internal and external networks, so the internet, cloud service provider networks, our intranet, our third parties. It also allows us to host internal and external facing applications, so DMZ services. And on top of that, it provides specific user services. So remote access services for our teleworkers, internet access for our internal users, as well as enables users on the internet to access our web applications, the applications that we host internally. So what is actually, what comprises this backbone node, right? So this node itself, it's a software-defined environment. It's a software-defined fabric, and it has local hosting, compute and storage capability, because we run a lot of our control and management plane functions at that point of presence. And we also run a lot of ancillary network applications, such as DHCP, DNS, network time, and a few others. And also, this node allows us to insert additional security functions when we need them virtually. And I'll cover some of that as we get to the security slides. The other key and important bit about this backbone node is it effectively interconnects to all of our networks. So you see here it connects to our data centers, and we use DWDM services or point-to-point services point-to-point circuits to interconnect to these data centers. The node itself hosts 2 NNIs. These NNIs represent the way this particular node interconnects into our global backbone. So we bring in NNIs from our MPLS providers there. We also consume direct connect services, right? So, and I'll cover this in a minute, but because we host this at a carrier-neutral facility, some of the key decisions that we make when picking a facility where we would host this node is obviously the availability of a local cloud point of presence, i.e. direct connect POP in this case. And also we look at the proximity of this facility to our own metros, i.e. the data center and our population centers. We also look at the breadth of the marketplace ecosystem within that particular facility. In other words, what services can we consume above and beyond this? So can we get access to carriers that we work with? Can we get access to services such as internet? Can we peer with other SaaS providers, internet peer, for example? So these are all kind of consideration we take into account when we pick a carrier-neutral facility. But also when, and I'll come to this in a minute, but we also look at whether we can achieve physical diversity for a particular metro. So because and I'll cover this in a minute, but we look to deploy dual nodes within our regional network because we want to maintain a higher level of resilience and availability. The node itself is really very comprised of, it's very high throughput or high capacity node. It's modular, so we've got all the components are kind of redundant. They're kind of sized at a minimum of 20 gigabits per second. We have the option to scale each of these components to support 40 gigabits per second. All the interconnects, the cross connects effectively that locally connect this node to all the various networks are at 10 gigabits per second. And the fabric itself is rated at 40 gigabits per second, and we have the ability to scale horizontally when needed to increase that throughput. So it's effectively a very high throughput environment. When we want to deploy a regional network, so what does that regional network look like? What we ultimately end up doing is we deploy 2 nodes within a particular metro. So we take the same node design and we replicate it at another carrier-neutral facility. We interconnect this node to the same internal and external networks, but we ensure that we do so in a very physically diverse manner. So we don't share the same carriers, we don't share the same infrastructure, we don't share POPs, because what we want to do is ensure that they're independent of each other. Okay? So effectively what you have is that each node has dual connections into the regional data centers. It has connections into a local direct connect POP for access to AWS. It's got dual NNIs, so no single failure of an NNI would cause an outage, for example. And at the same time, for each VPC that we host at a given AWS region, we provision a virtual private interface. And we use that interface to logically establish layer 3 connectivity between that regional network and the VPC. So consider that at a per node level. And so what we ultimately do is we exchange routing information using BGP, and we do so in an active-passive model. So we advertise default routes into the VPC because we want to avoid any VPC prefix limits. And we also set routing preferences using that protocol. So I would say that in terms of the availability of the actual regional network itself, I think this is rated at 5 nines. If looking at AWS specifically, our interconnects into AWS at each of these nodes is about 4 nines. And when you combine this with a dynamic failover with BGP and a few other methods, we achieve 5 nines. Now, obviously, this is rated towards the DMARC, which represents our interconnect into the AWS POP. But I think historically, over the past 4 years, we've effectively been able to achieve the same level, or at least measure the same level of availability of the AWS network. So it is about 5 nines when you take into account that dual-homed topology and the dynamic routing that we implement. So in addition to that, we also leverage a number of methods to ensure that any single component failure doesn't result in an extended outage. So we implement methods like BFD. We use lag, for example, to combine circuits. We mess around with a bit with protocol timers, convergence timers, to reduce that reconvergence time. And all of that attributes to that availability rating that I've talked about. So that's what a regional kind of design look like. It's effectively 2 backbone nodes, high throughput, heavily interconnected, and they connect kind of equally to all of our environments. So when we take this design and we try to deploy it to another region, for example, we have to make some adjustments to our design principles because we want to take into account some of the specific region-specific variances, right? So if you look to the left-hand side here, in the US, we don't have 2 data centers. We have 4 data centers. We don't have 2 metros. We don't have 1 metro. We have 2 metros. And we have distances we're dealing with, right? So we have presence in Chicago. We have presence in Houston, and it's about 1,200 miles away. So replicating exactly the same design doesn't necessarily work. So what we've done is we've spread that dual node topology across 2 metros. So we have 1 in Chicago and we have 1 in Dallas. And what we've done is kind of re-architected that interconnectivity, i.e. the back-end connections between that backbone, these backbone nodes and the data centers and our metros so that we achieve that higher level of resiliency and capacity. So what maybe looks like 4 DWDM individual circuits may translate into about 8 or 6 depending on which year we're talking about here. But effectively, we have to adapt that design in order to achieve that that availability rating. So as of today, we've effectively deployed 4 backbone nodes to service in 3 metros, right? Chicago, Dallas, and London. And we service 2 regions. We service the EMEA, and also we service the Americas. We're currently considering extending this architecture into another region, primarily Asia Pacific, and we're looking at the Singapore metro as a potential place where we'd host our backbone nodes there. So in terms of the traffic flow, however, I'd like to kind of cover a few of these. So one important factor here is to point out is that any inter-VPC communication, whether it's VPC to VPC in the same AWS region or it's VPC to VPC in a different AWS region, that traffic remains local to the AWS backbone. So we use VPC peering or global VPC peering to ensure that happens. We do not proxy this communication via our regional nodes. Obviously, we want to achieve high throughput and low latency, and that's kind of the model where it fits best. Contrary to that, however, all traffic that's destined to the internet or from the internet into the workloads in the VPCs these flows are proxied centrally through the node, the regional network, and I'll cover those later. The other thing is that any AWS region that we have a VPC hosted in is accessible globally to any user or location or branch office. So that means there is no need to hairpin the traffic or send the traffic through a data center, for example, or intermediary point to get to that region. What effectively happens is all the users connect through this global MPLS network and then egress that network at the point that's closest to that region. So usually the closest backbone node. What we haven't done so far yet is leverage the AWS backbone as a means to facilitate interregional communication between BP and AWS. And what I mean by that is, today, if we had a user that sat, let's say, in the US, or we had a metro that sat in the US, a user at a metro in the US, and wanted to connect to an AWS region, let's say in Dublin. Today, that traffic routes via that backbone node onto the MPLS network, then egresses the European points of presence in this case, and then goes on to AWS. The alternate to that is, of course, to egress locally, get onto the AWS network quickly, and then use that backbone to route over to that VPC. We haven't done that yet, but that's another alternative option that could be considered. So one other thing to also point out is our existing application footprint that resides in these data centers. We don't force that traffic to go through these backbone nodes yet, because we're still maintaining the MPLS points of presence at these data centers for the time being. Okay, so I don't know how we're doing for time, but I think we've covered a little bit around the architecture, and probably want to jump in and talk about how do we actually secure this environment. What does that node segmentation look like? So we talked about it's a software-defined fabric. We talked about that node is a point of presence for the network, and it interconnects a number of disparate networks effectively of different trust levels. But how do we actually secure the data flows that traverse this node, and how do we maintain that segmentation? What we effectively do is we actually break down this architecture, this fabric, into 3 different virtual security zones. We call these tenants. And the tenants effectively are just a grouping of resources, yeah? A grouping of network, hardware or software resources, applications, users, circuits, that we feel are effectively have the same trust level and have the same access privileges and have the same access policies apply to them. And so what differentiates these trust levels is effectively the level of trust we place on the resources that are housed within these tenants. So we have a trusted tenant, and what that effectively means is that we have a set of resources that BP as an organization controls and secures and has absolute administrative access to these resources. So the BP network effectively all is housed in that trusted tenant. Then we have an untrusted tenant, and I think it's quite clear what that is. It's the internet. But what that really means is we as an organization, we have limited control over these resources and the users and the endpoints, and we have actually limited visibility of what goes on there. So we consider them untrusted. So the internet is obviously third parties kind of flow into that category. And then we have a semi-trusted tenant, and well, it's effectively things that we do trust, but not quite yet. What it effectively means is that we actually share the responsibility of securing these resources with other third parties. Yeah? So in this particular case, a virtual private cloud fits that model, because at the infrastructure level, we have no control. We operate at a higher stack. So these virtual tenants effectively run their own administrative domains. They have their own virtual routing domains, and they're anchored by a set of dedicated hardware components. So you've got dedicated routers, dedicated switches, dedicated circuits. Effectively, all of these are delivered within that node at a per tenant level. And we have something what we call a security gateway or security gateways. And these effectively are your traditional next generation firewalls and always active protections, IDS and IPS. And these gateways effectively tie or link up these tenants together. So they effectively serve as a method by which we isolate communication or separate these tenants from each other. And these gateways sit in line. So any traffic that flows between these tenants, and there's 3 tenants here, so there's a number of flows that are possible here, about 8 different types of flows. All of these flow through these security gateways. So as a result, we apply default level restrictions, and it depends from where you're going to where you're headed, right? So the type of restrictions that we may apply between a transition from a semi-trusted to a trusted may be completely different than the level of controls that we apply from an untrusted to a trusted tenant. So that varies. So quite a bit of policies to manage. But what's also important here is that while these effectively exist as fixed set of security controls that we implement, we also have the ability to implement controls ad hoc, right, on a per flow basis. So what does that mean? It really means that if there is a particular flow that we're interested in protecting, and that flow, let's say, moves from an untrusted environment to a trusted environment, then we have the ability to spin up a number of security applications or functions, such as web application firewalls. We may want to SSL terminate the connection and inspect it. We might want to apply some host-based load balancing or routing. We may want to execute some web content filtering policy or what have you. So we have the ability to do so. And the way we do it is we instantiate what we call a DMZ function, and we tie that DMZ function to that flow. And as a result, we achieve the controls that we want to achieve. Now, I think it's worth noting that our security approach is really, it revolves around two principles, right? So first is that we rely on protection and detection as both mechanisms as means to protect our data and to ensure the confidentiality and the integrity, authenticity of our assets, right? So what that means is that not only do we apply active controls like that we've been talking about here, but we also apply passive type controls, which means we rely on elements within these boundaries where we can capture the data, analyze the data, inspect the data, correlate the data from that raw data, and also even correlate other events as they come in. And then as a result of that, gain insight and then create customized protections based on these insights. So that's why it's critical for us. And the other thing is that we obviously apply or conform to a least privilege model, right? Which means what really translates to here is that we have quite a number of micro-segmentations that we deploy, and also that we have quite granular restrictions and access policies. And so we try to use that model to secure all of the environments that we own. So whether it's an environment in our private data centers, or it's an environment like this where it's co-located at a third-party facility, or even virtual data centers in our VPCs in AWS. So this backbone node and the design here effectively conforms to these requirements, right? I'm not going to go through all of them here, but they're quite extensive. But suffice to say that this design meets those requirements. And we've been able to as well, to some extent, or actually to a large extent, replicate a lot of these active control functionality out into the cloud. So what does that mean? I mean, we didn't opt to deploy an NVA, for example, or a virtual appliance to provide east-west protection or north-south protection. We relied on security groups and NACLs, for example. I mean, similarly, we didn't have to go and deploy routers within AWS VPC in order to achieve, isolation of different routing domains. We relied on the VPC concept and subnets, for example, that, as opposed to VLANs. We leveraged other services like VPC flow logs, like CloudTrail, CloudWatch to achieve that richness and information around the events and the incidents that occur. And we integrate these data points back into our internal tools, our SIM tools. So what that really means, however, is that while we've been able to do a lot with the existing controls within AWS, that overall security strategy has a passive component that we haven't been able to replicate yet in AWS. And I stress the word yet because I think over the next 12 to 18 months, I think we'll get there. Okay, so I'm going to cover, so I guess one more point here is that because of that, we have to proxy some services or some flows centrally. And I'll briefly cover those because I think we're running out of time. Here's one. So outbound access to the internet. I just want to highlight the fact here is that this is moving from a higher trust tenant into a lower trust tenant. It goes through a number of security points. Here, what you see in the middle is what we call an egress DMZ. And that egress DMZ applies a number of applications or functions to that data. It does malware protection. We do FQDM-based filtering, a number of traditional functions that we apply to communications that egresses our boundaries. I think what's important to note here is that at any transition point, so whether it's between, let's say, across that fixed boundary or within that DMZ, pre-proxy or post-proxy, we have the ability, and we actually do, capture traffic traversing these boundaries at line rate. And we take that data, we correlate it with other data sources, so log information from these applications, for example, and we correlate that in order to achieve additional insight and intelligence on what's going on. I'll leave that here. I think we're running a bit out of time. The next one is another key one, actually, is inbound access to the internet. And that's one flow that we have opted to centralize via these regional backbone nodes. So again, this whole concept, we have an ingress DMZ, because that DMZ and the applications that reside within it effectively act on the traffic as it enters moves from a lower trust level to a higher trust level. So you'll see here we have SSL termination, we do inspection, we do re-encryption, and we do sandboxing and a number of other functionality here before we clear the traffic to get back into our higher trust environments. Okay. So I think, what does it look? How did we get here? I think I want to stress that we've really been only covering this at a very high level. There's a lot of details and data that exist behind what you're seeing here, and we just don't simply have the time to do so, to cover here. But I'm going to breeze through this. I think it's important to note these are the transition points along this journey. I think our target is to enable mass adoption, which means all of our applications can be in the cloud. They can be in any cloud. Anybody can attempt to consume any cloud. Where we started with is effectively early adoption. We've got a number of groups that want to effectively try out various functions within AWS, and we had to deliver some functionality or some connectivity to them. Traditionally, that meant, and then the low bandwidth, low availability solutions like internet VPNs, these were shared, and there were no SLAs associated with them. The support model was quite rigid because we're trying to implement a new pattern in cloud connectivity using legacy operational processes. So fast forward 2 years or 3 years in 2017, we now have a global architecture. And that global architecture is quite scalable. It's modular. It's high throughput. And we're able to federate it to any region we need to quite quickly. And it also represents really a shadow network, if you'd like, because it's the first network that we have that is completely independent of our data centers. So we can now start exiting these data centers, moving services along the way. What's important, I want to just briefly cover 2019. What is it for us, 2019? I think Paul will talk to it a bit more as we jump into his bit and we conclude this presentation. But 4 key things we want to do here. Let me start by saying is that we're going to really move away from this outcome-based services and move towards an in-source or a hybrid operating model where we have an agile development and operation of the network. Yeah. The second thing is we want to re-architect our network within the cloud. So we want to change that to achieve that mass adoption. And then the third is we'd have to re-architect our branches. What does the branch look like? I mean, ultimately, the goals we're trying to do is we want to do direct access from the branch to the cloud, as opposed to having to come through the backbone node. We want to increase our visibility of this communication, and we want to be able to route traffic based on the conditions of the network, so performance-based routing, additional visibility, software-defined overlay networks. So that's 2019. We also want to automate a lot of these operational processes, yeah? So we want to automate the firewall change process, for example. We want to automate provisioning of a lot of these functions that you see, whether it's creating a new VIF or SSL termination profile or what have you. We want to automate that. And we also want to re-architect our design in the cloud, in AWS, to support transit routing. So that's a hub and spoke model. Okay? Okay, how much are we doing? How are we doing for time? We got 12. Okay, good. So I've got a couple of slides I want to cover, and I think I'll cover those quickly. So what really has worked well for us, and I'm just going to cover a few points here. That marketplace was actually very good because it's really fundamental to our design. We're able to deploy to any region We don't have to bring in our connections into our data centers. We went to a location that had all the connections. If we wanted to consume an internet service at 3 gigabits per second, we could. If we want to drop it to 1 gig, we could. If we want to go up to 10 gig, we could. So that flexibility was key. And look closely at that space. These marketplace carrier-neutral facilities are expanding their own offerings. So what didn't exist 4 years ago, if you looked 4 years ago and thought that these services weren't there, look again, because these are changing and evolving quickly. The other thing that was key, I think, is speed of deployment. The reason that was key for us, because there was no way we were going to release two different releases of that backbone node at 6 different locations at the scale of BP's network on a live environment in 18 months without doing something right. And what was right is we kept it simple, so we didn't overcomplicate the world. We didn't deploy every single feature out there. Yeah, so we kept it very basic. Also, and we kind of applied similar patterns, right? It's just the design could be repeated. We didn't deviate a lot from there. And it was not popular in some times, so we had to push a lot back, but it was critical for us to ensure that we delivered something that was scalable and on time. And the other thing that I think I'll just cover here is the capacity and reliability of native solutions. So when we started this, one of the questions I said, well, we didn't really understand, we didn't really trust the cloud. We didn't know what that meant from a security and reliability perspective or a capacity perspective or services. What did that mean? Well, we understand now what it meant. It is scalable. It's reliable. It certainly is as reliable as some of the services that we run today outside. Now, there are some things that don't exist. In other words, you can't implement quality of service on the AWS backbone just for your own traffic. But you've got massive capacity. Do you really need it? So you need to start thinking in those terms. So I'll cover. I think this is good here. Obviously, the phasing was key as well. And consistency of performance, and that's just. Well, let me cover a little bit as what has been a bit challenging. As you can see, there's quite a few. So optimizing traffic flow was actually a very challenging environment, especially in a model where we've actually decided to proxy a lot of these flows centrally because of the security controls and applications we wanted to implement. Yeah. So in other words, I have a workload and application that sits in Dublin. It wants to talk to a public AWS service, yet I'm sending it to London first. So that's all right. I mean, it's 6-10 milliseconds on a good day. But what about in the US? We're hosted in Ohio, but our nodes are in Chicago and in Dallas. You know how much latency that is? Imagine if that's a database call, what that actually means. So that's been a challenge. But again, so the more we're able to move a lot of these controls out to the cloud, the more that we're able to break that pin. And we're starting to see that happen. The other thing is data migration. So it sounds like it's not a big thing, but it actually is. I mean, at the end of the day, it's not a data center with one single connection end to end to a target VPC. It's a metro connection to the backbone to the node. It's a direct connect circuit that goes across a carrier-neutral facility and then jumps onto the AWS backbone and then gets into a virtual construct. So it's really hard to ensure that you have the end-to-end performance of that network, that connection that you need. And not only that, right? So this is the WAN aspects of this communication. There's other aspects that you need to be cognizant of. So what type of applications and services and processes run on the source system where that data reside? Does the actual server have enough capacity, NIC capacity? Is it sitting in a data center block that is constrained some way, somehow? So these are all type of things that affect your ability to migrate the data at scale. I mean, there's a number of other factors, but just want to clarify here is that the network is critical to this data migration. So if you have a data migration team that's responsible for migrating your applications, you need to embed network resources in that team. Okay, so that's critical. And I think the other one here is managing user experience. So I mean, we've got some critical applications that we host in our data centers, and the users effectively sit half a mile away from that data center. So they're used to like local area network level speeds, yeah? Sub 1 millisecond access. All of a sudden, we've unplugged that data, that application, and moved it to Ohio. And they're expecting that they're going to transact with this data at 1 millisecond response time. That's just not going to happen. So you need to set the user expectations and look to perform some application performance testing before you decide to move this application to the cloud. Because if the application is chatty, if the protocol is sequential, tough luck. You're going to get some very unhappy customers. And operational visibility. I guess the last one is also important, IP address consumption. I mean, when we started this, we said, whoa, we've got RFC 19 address space. I mean, how are we going to run out of space? We've got plenty. Well, okay, so now we have dual cloud strategy, then we have dual regions, and we have 3 AZs. Okay, so we're running out. Okay, so be careful here. I think I'm about to conclude here, so I think I've covered quite a bit. And I kind of want to give it back to Paul, who's going to discuss what's next for us, BP, and then provide some key messages.
Cool. Thanks, Alain. So I think in the interest of time, Alain's kind of touched on a number of these. So, I mean, firstly, we would definitely go for, whilst we've centralized a lot of our service chains at our kind of core interconnect aggregation points, we would definitely recommend that you try to go to a model where you move a lot of your network services straight out into the cloud providers, and that's definitely what we're planning to do next. Use of cloud-native products over non-native products. Again, we've got a lot more confidence. We believe that the security, the reliability of those products has kind of surprised us, and as we look at our functional requirements, we see benefits of using native cloud products far outweigh any perceived functional gaps. We've moved to a DevOps-aligned operation model. That's a whole other story which we won't have time to talk about now. And architecture. Architecture is no longer for us domain-specific and characterized by fixed transitional states. We're seeing that architecture is in constant flux, and initial boundary conditions will change over time, and as such, the architecture needs to be flexible to respond to those boundary conditions. We're also finding that architecture needs to take an enterprise-wide view and consider the wider transformational implications of moving to cloud. In terms of where we're planning to go next, so I'll mention this, we want to try to externalize as much of that functionality from those backbone nodes directly into the cloud providers using native cloud network services. That will directly allow us to get after our 3rd generation cloud architecture, which is effectively to move to a multi-account vending model where we can vend out accounts to our different application teams and give them, or effectively go for a much more empowerment model where we can give them full fat access to Amazon services. Together with that, we're looking to we're looking at the opportunity to move more of our inter-region traffic directly over the cloud providers' backbones. And taking all of that together, that will allow us to get after a regional data center footprint because it will give us much more agility and lower the cost of entry to be able to drive network services into those regional cloud deployments. And then the final thing is we are just about to commence the rollout of an SD-WAN edge across most of our carpeted offices. There's about 640 carpeted offices globally. That will allow us to move more of our traffic directly over the internet as opposed to MPLS. And alongside SaaS-based security controls, we can optimize the end user experience as we move more of our IT services to be directly internet facing, which is where we're heading. So that's a really fast run through of where we're going next. I think at that point we take some questions. We've probably got time for maybe 1 or 2 questions. Yeah, go ahead. There's a mic there.
How do you suggest handling getting data, particularly larger data sets, off the capture platforms out on vessels or out in the field where there is no 5G connection? How can you get that data back in a timely fashion for processing at the right cost?
Do you want to handle that one? Yeah, your mic's up.
Okay, so You'll have to do it on a case-by-case basis, and it really depends on the actual sites, in our case, where that applies. So if you take the Gulf of Mexico, we've rolled out fiber networks effectively to all of our assets. So we needed that high throughput capability. So in that instance, we would take that data across that fiber network to a central facility, and from that point on, that facility interconnects into the closest backbone node that's available. In some instances, it may be a carrier-neutral facility as well to proxy that communication. But in that instance, we recognize that our assets there require fiber connectivity. Now, if you look at another region, for example, look at Alaska. We operate in Alaska, in Anchorage. That's a challenge for us. I mean, right now, it's a challenge because that location is disadvantaged when it comes to connectivity. But we're working with local carriers, with satellite providers, with low orbit satellite type technologies to come together and actually create a business solution effectively that addresses our requirements and others. I guess the answer to that is it depends on the use case, and it depends on where we're talking about. So we don't have a generic solution to address that yet.
What if there is no connectivity at all? Does that ever happen?
Well, I can't really answer that question.
Yeah, I mean
you'd have to ship it.
Links.
I mean, we have instances where it's just too much that we'd have to actually physically ship the data. But we're hoping with 5G, low Earth orbit satellite, and other technologies that problem starts to go away.
And just on that to jump in, and there are a number of projects with ongoing at BP using Snowball, so they're using that to move data where there's no network. So we're making good use of that in a number of use cases as well.
Okay, Paul, there's a question over here.
Probably we've got like 20 seconds. Talk quick.
This will be quick. On a percentage basis, where are you at along in your data center exit? Are you 50% out? Or are you,
So we've got 4 primaries. So two in the UK, one up in Chicago, one down in Houston. Our data center exit has focused on Houston. We're probably about 60% of the way out of Houston. But we're taking an app-led migration approach at the moment. So as we drain Houston, we're actually draining some of the other data centers as well, because typically an app will have multiple environments in different regions. So taking Houston out is taking some of the others out.
Great.
Okay.
Thanks, everybody. Have a good rest of day.
Cool.
Thank you.
Cheers, all.